Okay, so suppose we had the square root of x plus 3, or let's say 2x plus 3 equal 4. And I'm going to solve for x. So the square root of 2x plus 3, that's 2x plus 3. Square root of 2x plus 3 equals 4. So when you watch the video, there are some steps that you saw in that video. So the steps said that you got to isolate the radicals. So you got to get the radical by itself. So the radical is that square root part. It could be a square root, a cube root, a fourth root, and so on. But one you're focusing on in here is square root. Well, when you looked at the steps that were in that video, you get the radical by itself. In this case, it already is, right?
Mm-hmm.
So then the second step said, all right, once you get the radical by itself, you look at the index. What is the index here of that radical?
2.
2, square root 2. So you raise both sides, which you do one side, you do the other. You raise both sides to a power equal to the index. All right, so in other words, it's going to look like this. So square root of 2x plus 3 squared equal 4 squared. Okay? And so then the square and the square root undo each other, so those are inverse operations, which basically means this: the square root of 8 times the square root of 8 is just what? If you had the square root of 8 times the square root of 8, what is that equal to?
8.
It's just 8. It's the square root of 64. It's the square root of 8 squared, right?
Mm-hmm.
Which is just 8. The square root of 110 times the square root of 110 is just what?
110 squared.
110. It's just 110.
Yeah.
So the square root of 2x plus 3 times the square root of 2x plus 3
It's just 2x plus 3.
is just 2x plus 3. That's the idea that you saw. But basically the square and the square root undo each other. Those are inverse operations. So you're just left with 2x plus 3. So 2x plus 3 equal 16. 4 squared is 16. So in the video, there's some other ideas that were discussed, like extraneous roots. So the idea is that when you raise both sides to a power, you may introduce false solutions. So that's why you have to check. So whenever you raise both sides of an equation to a power, you have to check your solution. So don't forget. And in your final, you don't have, if you forget to check, it's no big deal because what you get is a solution. But just remember, in general, especially next semester, that idea is going to come back again, where you are going to have extraneous roots. So notice I went from a radical equation to what kind of equation?
Linear.
Linear. On the video, there were situations where you went from a radical to what kind of equation? Quadratic. And then that's where you had two solutions, and one of them were probably extraneous. And so you saw what to do there. The one in your final, though, you're going to go from a radical to a linear. That's the one it's going to look like. But just be aware that if we had more time, if you had to turn in that worksheet would be problems where you would go from radical to a quadratic. And then you would have to check for extraneous roots. So extraneous being that your solution is not a solution to the original. That's what that means. But it is linear, so you subtract 3 from both sides. And I get 2x equal 13, so it's x.
13 over 2.
13 over 2. Now, you did raise both sides to an even to a power, so you have to check. Now these are going to work, but you should check. If you forget, it's no big deal. The one in your final, I think the solution can be an integer, so it'll be easy to deal with. But basically, you got to go back to your original. So you have to check. So here's the original equation. That's the original equation. And so wherever you see the variable x, you're going to substitute 13 halves. So you're asking yourself the square root of 2 times 13 halves plus 3, and you want to see that's going to equal 4. That's what you're asking yourself. Well, what's 2 times 13 halves? 13. And what's 13 plus 3?
16.
And what's the square root of 16?
4.
4. Now, some of you, when I graded those worksheets, some of you were saying something like this. the square root of 16 is the square root of 4. That's not true. The square root of 16 is what? 4. The square root of 100 is not the square root of 10. The square root of 100 is what? 10. So when you get those worksheets, you can see those errors you made and figure out what your issue is with them, because those are going to be important in college algebra. And is 4 equal to 4?
Yes.
Yeah. So that's your solution. All right. So on your final, you're going to have one like that. It'll look something like this. All right. So I'm only doing one. Y'all can do this, all right?
Yeah.
Okay. So that takes care. So right here, so you'll see right here it says use a square root, solve a square root equation, that was you just did. Use the notes from last class period, meaning this class period. So you're going to use these notes to study. There's also a video in Module 5, and that's the one I asked you to look at, remember? And it says it's now posted. So if you need to go back and review this, keep in mind, though, that video goes beyond what's on the final. Because if you remember that video, if you looked at it,
About the first 15 minutes covered what was on the
yeah.
phone.
So the last part was usually where you went from a radical equation to a quadratic. But on your final, it's going to be linear. All right, so that takes care of this one. All right, let's talk about solving a, there was one, okay, the one I want to look at is where you, I think you had on your test where you had to take the square root of both sides.
Mhm.
Yes, okay. So I want to, some of you are doing this. I'm not sure why, and I think that some of you that are doing it are in here right now. But some of you are doing this. So let's it'll say solve using the square root property. That's what it's going to say. And so let's put, and I'm going to do an easy one first. So let's say number 1, you had 2x minus 1 squared equal, let's say, 9. Okay, I made that up. All right, now notice that this is what kind of equation, number 1? What kind of, what equation is this? What kind of equation is this?
Oh,
No, that's not linear.
no.
That's quadratic.
Quadratic.
If you multiplied this binomial out, you would get 2x times 2x, which is 4x squared. Just quadratic. But it's in that form, it's in this form where you have something squared equal a number. So whenever it's in that form, you don't want to use a quadratic formula. You don't want to multiply this thing out and then at some point use a quadratic formula. It takes too long. If it's in this form right here, the easiest way to solve this quadratic equation is to use what property? Square root property. Okay, so this is what you're going to do. You're going to take the square root of both sides, plus or minus, right? And the square and the square root undo each other, so you get 2x minus 1 equal plus or minus 3. Okay? Now, here's where some of you make the mistake. You're adding 1 to both sides, which is true, and then you're doing this. You're saying plus or minus 3 plus 1 is plus or minus 2 or plus or minus 4. You're saying this. You're saying 2x equal plus or minus 4. You can't do that. That's not true. So on your worksheet, and actually on the test, so if you look at your test right now, you'll see if it's one of yours that did that. You can't do that. At that point, this is what you're supposed to do. This is what you're supposed to do. You're supposed to, see, this is rational, right? Remember we talked about rational versus irrational?
Mhm.
This is rational. You're supposed to split it apart.
Oh,
That's what you're supposed to do. So you're supposed to say 2x minus 1 equals 3, and then 2x minus 1 equals what? That's what you were supposed to do. And then you solve each linear equation. So you add 1 to both sides. You get 2x equal 4. So what's x? 2. So that's one of your solutions. Over here, you add 1 to both sides. You get 2x equal negative 2. So what's x? What's x over here?
-2.
No, not negative 2. If 2x equals
I mean,
negative 1. All right, so that's what you had to do. Now, the one in your final will look more like this. All right, 3x minus 4. All right, now how do you deal with the right? See, it's a little bit different than this one. Why is number 1 a lot easier than number 2? Because 9's a perfect square. 24 is not a perfect square. But you need to be able to simplify the square root of 24. How can you simplify the square root of 24? 4 times 6. So you look for a perfect square that goes into 24. And always use the largest. The largest is 4 here. And what's the square root of 4?
2.
So square root of 24 is 2 square root of 6. So this becomes plus or minus 2 square root of 6. Okay? Now what's the next step? Okay, now first of all, notice that when we did number 1, we ended up with a rational number because 9 was a perfect square. So we split it apart. And we came out with we did actually the work. We came out with rational solutions. You can do the same thing here. You can do the same thing here. You can say, it does not matter because some of you did that. You can say 3x minus 4 equals what? No. Split it apart.
Plus 2 square root of
2 square root of 6. 3x minus 4 equals what? Negative 2 square root of 6. Just like you did with this one. There's nothing wrong with doing that. But you got to get x by itself. So what's the next step? Add 4 to both sides. Now be careful. 2 square root of 6 plus 4 is not 6 square root of 6. Those are not like terms. So you have to say 3x equals what? 4 plus 2. No. Okay, so yeah, you can say that, yes. So what she's doing is she's writing it as 1. So I'm going to do this. Or you can say 3x minus 4 equals plus or minus 2 squared root of 6. So she brought the 4 over. So she did this. And so she has, at this point, she has 4 plus or minus 2 squared root of 6. That's what she has at that point. So she's keeping it as plus or minus. You can, if you want to, split it apart. So here you'd say 4 plus 2 squared root of 6, and then divide both sides by what? 3. And there's your answer. You cannot simplify, so there's your answer. So x is 4 plus 2 squared root of 6 divided by 3. So there's one of them. Do the same thing with this one. Here you're going to do what? Add 4. So you get 3x equals 4 minus 2 squared root of 6. One more step is to do what?
Divide both sides by 3, and then there's your answer.
Yes. So x is 4 minus 2 squared root of 6 divided by 3. Now, for her, she would have just divided both sides by 3 like this, and her answer would have been 4 plus or minus 2 squared root of 6 over what? 3. That would have been her answer. Okay? All right, any questions? All right, so that's on your test, just like it was on test 4. But the one in your final is not a perfect square. So notice the square root.
Couldn't make it easy like that, huh?
All right. Now, let's look at another one that's on your final. That's on that sheet. Okay, so let's do this one here. Rationalize the denominator. Now, I have the word rational. It really should say rationalize. So take the word rational out and put the word rationalize. That's what it should say.
Where at?
See where it says new material?
Okay.
So,
Rationalize.
yeah, I have rational the denominator. That's not what that should be. That it should say rationalize the denominator. Here's okay. So it's not that difficult to deal with. So here's the idea about rationalizing the denominator. Now notice what I have. I have used the notes from the last class period. So when studying, use these notes here. and then I will have a video on Canvas on it, but I don't have it yet. It will be posted this weekend. But if you can remember, or if you understand what we're doing now, then there's no reason for you to look at that video. So here's the idea about rationalizing the denominator. And this is section 10.5.
The last part that we just did, what was that, please?
That taking the square root of both sides.
Yeah.
Previous material.
That was previous material, but that was this one right here, the third bullet on test 4.
Okay.
Solve a quadratic equation using square root property. Okay, that was that third bullet. Okay, so this is rationalizing the denominator, section 10.5. Okay, now here's the idea. We're going to start with the simple one, and then we're going to work to the one that you're going to see on your final. So, if you have number 1, so you're going to rationalize the denominator. That's going to be the directions. Rationalize the denominator. So let's suppose we have 3 over the square root of 5. Okay, 3 divided by the square root of 5. Now, rationalizing, and the word rationalize is the word rational. Okay?
Mm-hmm.
Now remember, we talked about rational number before. The directions will say rationalize the denominator. The denominator here is the square root of 5. What kind of number is the square root of 5?
Irrational.
Irrational. So it's not rational, right?
Right.
It is irrational. Well, the denominator is one term. What you want to do is get rid of that square root. So you want to make that denominator a rational number instead. Right now, what kind of number is that denominator?
Irrational.
Irrational. You want to end up making it a rational number. That's what rationalize the denominator implies. So here's what you do. Here's the best thing to do. The easiest thing to do. So remember, what you do to the denominator, you have to do to the numerator. All right. So if I want to get rid of that square root, based on what we even just talked about,
Square?
I can multiply it by itself. No, you don't square it.
No.
You're going to multiply it by itself. Because what's the square root of 5 from the square root of 5?
20.
Well, we talked about that. What's the square root of one?
5.
Yeah, what's the square root of 2.7 to the square root of 2.7? Right away, you're supposed to say what? 2.7. So that's 5. And 5 is what kind of number? A rational number. But what I do to the denominator, I have to do to the numerator. So now your answer will be, you rise one fraction, 3 times what?
Square root of 5.
Divided by
5.
5. There's your answer. That's what rationalizing the denominator means.
How many of those are going to be on?
No. That's not on your phone. That's the easy one right there.
Well, yeah. I'm kind of hoping for it.
All right? That's not what it's going to look like.
All
All right, but there is one problem.
Okay.
There's one problem. All right, so we're getting to the point where, but I had to explain what rationalized denominator is from an easy problem. Okay, that's the easiest problem you can have with rationalizing the denominator. Okay, so the one in your final, will look more like this. Okay, 5 divided by 2 minus the square root of 3. 5 divided by 2 minus the square root of 3. So notice number 1, the denominator was one term. Number 2, the denominator has how many terms? 2. But it's still an irrational number because there's a square root of 3 there. You see, if it was just 2, then it would be what kind of denominator? Rational. If it was just square root of 3, it would be what? Irrational. But a rational number and an irrational number is going to be an irrational number. All right, so this is still an irrational number. But it's a binomial. Multiplying, remember how we multiplied here by the square root of 5? multiply, you may think, if we had more time, we would discuss it, but you may think, well, can't you just multiply by the square root of 3? No, because this right here would be 2 what? Square root of 3, and that's still irrational. But here's the idea: when you have a binomial, and one of the terms is a square root, to make it rational, you're going to multiply by its conjugate. So here's what I mean by conjugate. The conjugate, C-O-N-J-U-G-A-T-E, the conjugate of, I'm going to make this up, 6 plus the square root of 3 is, and all you do is change the sign of the radical. So it'll be 6 what? Minus the square root of 3. And here's why. Think about this. You remember when you dealt with the difference of two squares?
Mm-hmm.
Doesn't it kind of look like the factoring of the difference of two squares?
Mm-hmm.
6 plus the square root of 3 times what? 6 minus the square root of 3. And I want to show you this. If you multiply conjugates, notice what happens. Use the fall method. What's 6 times 6?
36.
What do you notice about the outer and the inner, guys? Tell me right away. What do you notice about the outer and the inner?
Same.
No. They're not the same.
No, well,
They're opposites.
yeah.
One's 3 squared root of 6. The other one is negative 3 squared root of 6. So what do you notice about the outer and the inner?
They cancel out.
Yes, it's 0.
Totally.
Y'all have been dealing with factoring, the idea of factoring here. Difference of two squares. So the outer and the inner cancel out. But what is the square root? So now let's do the last, FOIL. So first, outer and the inner cancel out. And you can rewrite it, guys, if you want to. It'll be minus 3 squared root of 6. I'm sorry, minus what? 6 squared root of 3, right? Plus 6 squared root of 3. Those cancel out. What's the last, though? What's a square root of 3 times a negative square root of 3?
No.
Oh, my Lord, y'all.
Is it going to be a negative 3?
It's negative 3. We just talked about this. The square root of 2.7 times the square root of 2.7 is what? 2.7. The square root of 3 times the square root of 3 is just what? 3. But a positive times a negative is a negative. So that's negative 3. And what's 36 minus 3?
33.
And what kind of number is 33?
Rational.
So I went from irrational to what? Rational.
Wait, so this is 36, what is that?
Minus 6 square root of 3 plus 6 square root of 3.
Which cancels out, so you don't need to write it.
It's just your outer and your inner. Okay? So whenever you have a binomial, and you're going to have one in your final, whenever you have a binomial and one of the terms is a square root, you're going to rationalize it by multiplying it by its what? Conjugate.
Not
Okay.
Not conjugal, conjugate.
Conjugate.
You know I'm gonna do it.
All right? Okay, now, so here's what you're going to do. So here's your step. So you're going to say times. Okay, what's a conjugate of 2 minus the square root of 3? 2 plus the square root of 3. So what you do to the denominator, you're going to do to the numerator. Okay? Now, this one's not that bad because this is a monomial times a binomial. So here's the idea. And some of you can skip this step, but I'm not going to skip this step. I'm going to write it. So you're going to write this as one fraction now. So it's 5 times what? 2 plus square root of 3 over. Now here, I'm multiplying two binomials. You notice they're conjugates, right?
Right.
So that means that the outer and the inner will do what?
Cancel out.
Cancel. So all you have to deal with is first and last. So what's 2 times 2?
4.
Okay, a negative times a positive is a? A negative times a
Negative.
positive is a?
Negative.
Negative.
Negative 3.
Square root of 3 square root of 3 is
Negative 3.
3. And so therefore,
1.
distribute here, you're going to get what?
10.
10 plus
Plus
5 square root of 3 divided by
1.
1, which is just what?
What it is.
Which is what?
The numerator.
Which is what? 10 plus 5 square root of 3. Okay? That will be your answer. Now let's do another one. Number 3. Okay, this time, suppose we had this. Suppose we had negative 6 divided by 4 plus the square root of 7. Negative 6 divided by 4 plus the square root of 7. And the direction will say rationalize the denominator. So you want your denominator to be a rational number. Right now, what kind of number is my denominator?
Irrational.
Why is it irrational? What makes it irrational?
Square root.
Square root of 7. That's what makes it irrational. So I want to make it rational. So to make it rational, since that's a binomial, I'm going to multiply numerator and denominator by its what?
Conjugate.
Conjugate. And what's the conjugate of 4 plus the square root of 7?
4 minus square root.
4 minus square root of 7. So you're going to say 4 minus square root of 7, 4 minus square root of 7, just like this. Okay? Now you can skip the following step, but basically this is what you're thinking in your mind though. You're going to write this as one fraction, and you're saying this, well, this is going to be negative 6 times what?
4.
Minus square root of 7. All right, now the numerator, the denominator, let's use the FOIL. These are conjugates.
First one.
The out and the inner will do what? Cancel. So don't even worry about the out and the inner. Now remember, that only is true if they're what? Conjugates.
So 4 times 4 is 16.
So you say 16, and the positive times the negative is a negative. In fact, since those are conjugates, won't this always be a subtraction?
Yes.
Okay.
Negative 7.
Right. So square root of 7, square root of 7 is 7. So you have 16 minus 7. You agree?
Yeah.
All right. And now distribute. You get negative 24
And minus 6.
plus
Plus
6 square root of 7. A negative times a negative is a positive. Over
9.
9. Okay, that's where we're at, all right? Now, you don't want to leave your answer like this. Remember when we did the quadratic formula? Remember we did all that? And we got to something that looked like this, and we said, these three numbers here, do they have anything in common?
3.
They have a 3 in common. So if you leave it like this, you'll get most of your points, because you did most of the work correctly. So you probably lose 1 point. Remember, this is 10 points. So you probably lose 1 point if you don't finish this. But these numbers are divisible by 3. So what's negative 24 divided by 3?
Negative 8.
Plus what's 6 divided by 3?
Negative 22.
2 square root of 7. And what's 9 divided by 3? 3. That should be your final answer. Okay? So if you can reduce, then go ahead and reduce. All right. So you can do that in the final, right?
How many of those are there?
Just one.
Thank God.
There's only 21.
Yeah, but you need to make sure you
There's
get
only
those
21
10
questions
points,
on the whole
though.
I think, yeah, that's what I was
I mean,
thinking.
you only get one chance to get it right.
Right.
Okay, so that was that one. So let me go ahead and so I took care of this. All right. Now, this we started talking about. In fact, some of you already had that worksheet to turn in, but I'm not picking it up. So go ahead and take out the worksheet that says 10.4. Take that out. Okay, you don't have this. Go ahead and take one of these.
Which one's that?
Hmm?
Which one's that?
That's the one we're about to go over. So these people, you don't know what they're gonna do in that final. They're gonna be in trouble. Okay, so this is where, if you look at that sheet you just got, notice you're multiplying radicals. Let's see that?
Mm-hmm.
Okay, so let's do the first one. The first one you just see there. So notice that all the indices are the same. They're all square roots.
Mm-hmm.
So since they're all square roots, that means I can write this as one square root. And all I do is just multiply the radicands together. So in other words, the square root of x to the 6 times y times the square root of xy is the square root of what?
X7 y squared.
Y'all agree?
Yeah. 'cause you
Yeah.
add 'em when you multiply.
Yeah. When you multiply like bases, you do other those exponents.
Yeah.
You add them. That's the product rule. And now you just simplify like we've been doing. So when you simplify, this will be the square root of x to the 7th times the square root of y squared. And that'll be x to the 7 halves times y to the 2 over 2, right?
Mm-hmm.
And then x to the 7 halves is what mixed number?
Would it be x cubed y squared root of x?
Yeah. But it's 3.5 though, right? But she kind of, in her mind, she was thinking that 3.5, I guess. So it's x cubed square root of x, right? Y'all agree? Yes or no?
Yes.
Okay. So that's x cubed square root of x, and then this is just what?
Y.
Y. Now, guys, when we write the final answer, we always put the radical last. Okay? So don't write it like this. Put everything in front of the radical and put the radical last. And let's put it in alphabetical order. So this is going to be what? X cubed y square root of x. Okay? That's how you do it. That's all you do. All right, now the next one. Now remember, you can only multiply the radicands if the indices are the same. And they are. Square root, square root. So this is going to be the square root of what?
Yeah, what she said.
So you have one of those, and it is an important idea for next semester as well, because next semester one of the first things you're going to do in the course, that first 2 days, one of the first 2 days is you're going to have to solve rational equations, which is basically a review from this course, although we're doing it on the very last day. So let me give you that sheet on it. Okay, so it's going to be the one that says 7.5 part B. So here's the part B. And I don't know why these people are out there. They should not be absent.
We should get extra points for doing
Yeah.
Well, your point is the fact that you got a heads up on what you need to be dealing with.
And the Saints are losing on top of all that.
I'm telling you, because I'm over here.
And the Saints are losing?
Like,
13 to
they
nothing
playing
at
like shit
halftime.
right now. What they got going on?
It's 13 to nothing at halftime.
Did you see kill the worksheet?
Well, it's just halftime.
Both of them. They really pissed me off.
It's just halftime. And then,
Man, I ain't playing like
wait, and then, didn't they